Welcome back. The objective of this video is to introduce the polar coordinate system, or what I sometimes call the coordinate plane, and we'll plot points on the coordinate plane. So as I prepared for this video, I wanted to have a good polar coordinate system, so I went out to Google and I Googled polar plane, and this is what Google gave me. Literally a polar airplane. Not really what I'm after, not exactly the polar plane. So sometimes Google is not as helpful as it could be. So we'll get rid of this guy. We'll delete that polar plane. And here is that polar plane. It's that target practice or dartboard that you may have seen in the classroom. That is the polar coordinate system. And it's set up similar to our Cartesian plane, except now we've got a circular thing instead of a perfect grid. The pole is the origin. Okay, so let's see if I can get this set up right. Our origin is the pole, and the polar axis is the horizontal ray from the origin to the right. So this is our polar axis, or the positive x-axis. And each point on the polar plane is some r, some distance, some radius r, okay, a directed distance from the origin to some particular point. And theta is a rotation. It's an angle that we're rotating on the plane. Okay, so keep in mind our positive angles rotate in a counterclockwise direction, and our negative angles rotate in a clockwise direction. And so our theta is a directed angle in a counterclockwise direction, unless of course that angle is negative. So we've plotted the point here 3 pi over 4. So it looks like each one of these rays extending from the origin is a pi over 6. Okay, and each circle here is a unit 1. So we have 1, 2, and we're 3 out on our polar axis. So point P is the point 3, because we're out for a radius of 3 from the pole, and we've rotated pi over 4 degrees.
Radians.
So that is the location P, that it's an r of 3 and a theta of pi over 4. So let's go ahead in example 1 and plot some points. Let's plot point P on our polar plane here. So we have a r of 2 and a theta of pi over 4. So I'm going to extend 2 out from my pole, and I'm going to rotate pi over 4. And that would be point P. Let's go on to C. Let's plot point R. Now that's got a radius of 3 and an angle of negative 30 degrees. Well, negative 30 is negative pi over 6, and fortunately for us, each of these hash marks is a pi over 6. So I'm going to extend 3 out on my radius and rotate a negative pi over 6, and that is going to be point R. In problem B, that one's a little bit sneakier. We've got an r of negative 1, and there's a couple ways to do this. I used to do this. I'd extend 1 out, and I would do my rotation to pi over 3, and then I would reflect across the pole, and that would give me my location. So we can say point Q is going to be actually located here. So we're 1 out, and then we rotate pi over 3, and then, but it's got to be a negative 1, so we reflect across the pole negative 1 unit. Some guys like this system a little better. Instead of going in the positive direction on the polar axis, they go in the negative direction. So they go to negative 1, and then they rotate pi over 3. Now be careful here. This is a positive pi over 3, so we're rotating in a counterclockwise direction. So it's a little counterintuitive, but we end up at that same location, point Q. And I'll probably do that more frequently. I think guys find that easier than reflecting across the pole. They just start in the negative R direction and then remember to rotate. Negative angles rotate now still in that clockwise direction from here, and positive angles rotate in the counterclockwise direction. So something to keep in mind. So there are actually multiple ways to graph that particular point. There are multiple locations. Now we have it as -1 pi over 3, but it also could be -1, but then we could rotate in the other direction, which would be 1 pi over 3, 2, 3, 4, 5 pi over 3. So we could call that -1 5 pi over 3. And I beg your pardon, that's actually a -5 pi over 3 because I was rotating in the negative direction. It could also be +1, so I go out +1 and I can rotate 4 pi over 3. So that location is also 4 pi over 3. And it could also be listed as 1, but then rotating -2 pi over 3. So those are all 4 different ways to express point Q. And we'll do that, a few more of those in later samples. Let's go to D. We'll only do one of these. We want to find -2. So I'm going to, instead of going to the +2, I'm going to go out to the -2. So -2. And then I'm going to rotate -7 pi over 6. So I'm going to rotate in the negative direction, 7 pi over 6, from essentially my negative, what was formerly known as my negative x-axis. And I'm going to rotate around. That would be -6 pi over 6, and -7 pi over 6 puts me right there at point S. In example 2, we're going to find all polar coordinates of a single point. And so as I talked about just a few minutes ago, we're going to do 4 representations of 2 pi over 3 between -2 pi and 2 pi. We get a formula here for those multiple representations. You can call it R and then theta plus 2 pi n, so all the multiple loops there. Or we can do -R and then theta plus 2 pi n plus pi, or 2n plus 1 pi. And I'm not sure the formula is real easy. I think it's a little cumbersome. But let's go ahead and plot this point and then see if we can figure out another positive representation for that location. So we're going to have one more positive R, and then we're going to have 2 with a -R. So let's see what we got here. So at 2, we'll go out 2, and then we're going to rotate in the positive direction 2 pi over 3, and that's going to put us at this location. So that's going to be our point. We'll call it point P. So we've got our first representation from our answer, so now, or from our question. And now let's take a look at what other could we call that? Well, we could call it 2, and we could just rotate in the negative direction. So one of the possibilities would be to -4 pi over 3. So from our positive polar axis, we just rotate in the negative direction to that location. But we could also have -R. So if I went out to -2, well, what does it take to get to point P? Well, I have to rotate from this location. I have to rotate a -pi over 3. So another representation of that same point would be an R of -2 and a theta of -pi over 3. Likewise, we could rotate in the opposite direction from there and rotate all the way around, and that is the positive direction, so we could call that -2, and a rotation of positive 5 pi over 3. Those are 3 different ways to land us at 2 pi over 3. So that wraps up our introduction to the coordinate plane and plotting points on the coordinate plane and representing points in different ways on the coordinate plane. And you'll get some more practice with this when I see you in class.